have done this already, but here it is anyways, okay? Keep this in mind, round all final answers to 2 decimals, okay? So when you're about to state your answer, that's when you round to 2. Always indicate keystrokes, okay? From now on, you got to make sure you tell me what did you press to get there. It doesn't have to be the same as mine, as long as you let me know somehow this is what I did to get there. Okay, here we go. The height of the herd of a buffalo jumping down a cliff can be modeled by the following equation. Here it is, where h of t is the height, right, in feet, and t is the time in seconds. Okay, so we know that this variable is my x variable, so time, and height is my y variable. Make sure you don't mix that up, because some students mix it up. Right? This is the x is always on this side, the y is always on that side. We will never trick you on that. Okay? Even in grade 12, guaranteed that's your y. Okay? It says graph the situation. Consider the scale, labels, and shape. Okay, if you need to graph, what do we want? We want intercepts and vertex. Right? That's a must to figure that out. So let's go ahead and do that. Let's graph it. Type it into your calculator. And so we go negative 4.9 x squared. What do we know right off the bat, guys, just by looking at the A here? It's pointing down, and it's narrower compared to a wide curve. Right? The narrow and the wide doesn't always make a big difference. Our calculator can handle that. But whether it's pointing up or down, I hope you catch that. Okay, if your curve is pointing up, I mean, how does a herd of buffalo jump up, right? Unless you're watching some sort of sci-fi movie, right? Like, it doesn't work. So there we go. I graph it. It's a terrible scale. My window is not good at all. I'm going to try zoom standard. Oh, I'm talking big and I'm not even finishing my equation. See, right there I could tell something is wrong. Plus 32. Do you notice that the x term is missing? We talked about that yesterday, actually. So this is going to be the y-axis is going to cut it in half. There you go. I'm going to change my window. This is a standard window. I'm going to increase my y max a little bit. I noticed that my y-intercept is 32. So I should probably change my y max to like 40 or 50 or something like that. That's a pretty good graph. Okay. So let's find the y-intercept. Let's do that first. This is 0.32 because it's in general form. The x-intercept. Would we care about this x-intercept here? In this case, we wouldn't. Right? It's a word problem. We can't have negative times, so we'd only worry about this one. So let's figure that out. y2 is equal to 0. Second trace 5. I'm going to just start saying second trace 5. You should know that that's intersect. So I'm going to graph second trace 5. I'll go a little faster on this one because the next one is a little trickier. Okay, I want to get to that one. So this will be 2.560. Okay, that's basically when this herd of buffalo hits the ground or lands on the ground. The time, actually, we know that it's the time because there's this time, there's this height. Okay. Do we need anything else? Yes, vertex, remember? How do we find the vertex in this case? Second trace, min or max? It's a max, right? Vertex is the highest point. So second trace 4 for max. You got to go to the left. And if you did the homework, you already know what's going to happen here. Uh-oh. I'm glad this happened. Okay, I'm going to zoom into that. I hope you're trying this right now. Do you notice what the x is there? It says 2.07, but watch, what does it say at the end? E negative 6. It's saying that x is 2.07 times 10 to the negative 6. It's a really, really small number. It is actually 0. Look at where the cursor is blinking. It's right there. x is equal to 0. We don't care about, I know that in chemistry you would use, right, all your decimal significant values, but we don't in this course, okay? So this is 0. I will actually write that down here in the notes, okay? So write that down just for reference as well. Note, okay, 2.0704 e to the negative 6, okay? That is really saying 2.0704 times 10 to the negative 6. That's what the calculator is trying to tell you. We consider this 0, okay? That is basically a 0. So when that happens, please just say 0, and it's 32, okay? 0.32. And what do you notice about 0.32? Hey, it's my y-intercept, isn't it? Yeah, that's okay. That's what it is, okay? It's because B is missing. So I will just leave that. There's a note on page 34 about that. Okay, so let's graph this. This is time in seconds. This is height in feet, okay, like that. And I need to fit this. So they land at 2.56. So I have lots of space here. I can go 0.5, 1, 1.5, 2, 2.5. I think that'll work just fine. Okay. I know we're going to be a little off, and that's fine. We have that space there. And then for my y, I need to include 32. So let's see here, 5, 10, 15, 20. No, that's not going to work. So I'm just going to go up by 10. And I do count the boxes, okay? So if you're going to try, if you're like, that's a prox, if I give you grids, make sure you do every, for example, I'm using every 4th box. That's what I'm going up by. Make sure that you do that as well, okay? 0.32 would be right there. And then 2.56 would be just off here at the very edge of our x-axis here for us. This is where it lands. So we're just going to go out and over like that. Not too proud of that one, but hey, it's okay. So then somewhere h of t, this is, right? Just put the equation in. Plus 32. And there you have it. And now I'm asking you a whole bunch of questions. So first I asked you to graph, and now I'm asking you a bunch of questions. It's actually, it doesn't matter. I could do either one. Okay? So B is asking, how long are the buffalo above ground? We would say, right, we state this point. That's the x-intercept. Okay? So 2.56 seconds. That's it. That's all I would need you to say. Just make sure you have units there. Just don't leave it as a point like that, because that's not answering correctly. Okay? Because we were not sure. Do you know if it's 0 or is it 2.56? Which one is it? C. What is the initial height of the buffalo? That is given to me by the y-intercept. 0.32. When time is 0, right? Initial time, they're at 32 feet above ground, right? At time 0 seconds, they are 32 feet above ground. Okay? Initial height. Oops, I'm a little off here. Hold on. At time 0 seconds, they are 32 feet above ground. D. This is a classic here. D is worth 2 marks usually. Read D with me. How long are the buffalo? At or above 15 feet. Okay? You should already know that I will make a mark. I will draw a straight line at 15 and then find those intersections. Okay. Time 1, so let's go ahead and do that. If you've already done it, then maybe just watch, right? So y2 is equal to 15. I'm going to graph that. There it is. Careful, okay? I only care, like they're going to be above 15 feet starting here, and then it ends when they're on their way down here, okay? That's the only stretch. I don't care about the negative, because they start their action up here. So I just have to find, time 1 is 0, folks. At the very beginning, it's at 0, okay? And then we're going to go second trace 5 and find that the next instance, which is 1.8626. So delta t is going to be 1.8626 minus 0. That's 1.86 seconds. That's it. So in this case, you don't have to find 2 points, because you got to pay attention to this part, because it's not like it happens once on the way up and then again on its way down, correct? They literally start above 15 feet right at the time 0. Like when they jump off the cliff, they're already above 15. So our action kind of starts, okay? This is the 15 line. So this is time 0, and then it happens again at 1.8626 if you want to add this to your notes. Okay? We only care about this stretch here, and that is given to us by that time that we just found. Okay. Just to give you a refresher, yesterday when we did the lesson, in this case, we wanted to know the time at or above 49. We start below 49, so we need to figure out, oh, we hit 49 right here, so record that time, right? And then it comes back down at 49 again, record the time, so we have to subtract those 2 times, okay? All right. 38 is done. Oh no, we're not done yet. Mr. Dirksen, stop skipping. Domain and range. The most important thing that we want to learn today is domain and range. And I ran out of room, so I'm just going to squeeze that in here somewhere. Here it is, E. I'm going to make a box here for E. The domain here, it goes from 0 times 0 all the way to 2.56. It's implied that that's when the action stops. It only models the jump. As soon as you hit the ground, it stops, right? Range, you go from as low as 0 when you hit the ground, and remember, the highest point in this case is 32, because I look at my vertex for the range. It happens to be that the y-intercept is also 32. It just happens to be the case, all right? So this goes from 0 to 32. There we go. Okay. So I hope this helps you. I will ask you, I think I'm going to pause now. Otherwise, I would like you to try this right away. I assigned